Hello everyone. Today we're going to continue with particle motion and focus on finding net distance and total distance. Now what the difference is that net distance represents the distance that was traveled from beginning to end, meaning that if let's say I travel 5 feet to the left and then 5 feet to the right, I would end up back where I started. So that would mean that my net distance would be 0. So by definition, net distance is the distance between the point of origin and the final position. Now, total distance, however, is the sum of all the different distances moved in any direction. So if I use that same example, if I move 5 feet to the right and then 5 feet to the left, my total distance would be 10 feet. So this is how you find these distances. Net distance, if you are given an interval, would be the absolute value of P of A minus P of B, meaning the position, that your starting position minus the ending position. And we use the absolute value to indicate that it will be a positive number, since distance is positive. Now, if you're trying to find the total distance, you would have to first check if the particle changes direction. If it changes direction at some value of t, let's say c, then we would find the total distance by calculating the net distance from the initial point to when it changes direction, and then add from that point where it changes direction to the ending point. Now, it's important to note as well that if your particle never changes direction, then that means that the net distance is going to equal to the total distance. So for the next two questions, for this question and the one on the next slide, we're going to be calculating distances, and you will need your calculator for those questions. So let's go ahead and do this first one. So if you don't have your calculator, go ahead and grab it. You can pause the video and then we'll move forward. So in this question, it says the position of a particle is given by the function P of t is equal to 2t to the third minus 6t squared plus 8t, where P of t is measured in centimeters. So I'm just going to underline here my units because I know that my distance will have to be in centimeters. Find the net and total distance the particle travels from t is equal to 1.5 to t is equal to 4 seconds. All right, so first let's start with net distance. So net distance is the absolute value of the position from the starting point minus the position at the ending point. So let's go to the calculator to do this math for us. I'm going to go ahead and graph my function. So 2x to the third minus 6x squared plus 8x. Okay, let's graph. Now I have my standard viewing window from -10 to 10 for both the x's and the y's. You can adjust your window if you like to 1.5 to 4 since that's the interval that we're focused on, but really the calculator is just going to get those values for me, so I'm not going to adjust anything quite yet. So let's go to the second calc menu. I need my value, so I'm going to put 1.5, and 5.25 is P of 1.5. So we come here, this is 1.5 minus, now let's get the value for 4, and we get 64. Again, this is a calculator question, so we can just go to the calculator and exit out of our graph, and then put 1.5 minus 64, and we get a net distance of the absolute value of negative 62.5, which is equal to 62.5, and then our units would be centimeters. So that would be my net distance. To find the total distance, we have to check if my particle changes direction. Now I know the particle will change direction if the velocity changes signs, because remember that velocity tells us the direction in which the particle is traveling. So let's find an equation for v of t, which is the derivative of p of t. When I find this derivative, I get 6t squared minus 12 t plus 8. So now I'm going to go to my calculator here. I'm just going to deselect this in case I need it again later. And we're going to now input the velocity equation. So 6x squared minus 12x plus 8. Now you can see that the function is the entire time over the x-axis, meaning that no matter what, the velocity is always positive. And if the velocity is always positive, then that means that the particle is always moving to the right. So if the particle does not change direction, then that means that my net distance is going to equal to the total distance. So we can state here, first, we would say since the particle does not change direction, then net distance will equal to the total distance. Okay, let's go ahead and look at the next question. The position of a particle is given by the function p of t is equal to e raised to the 2t minus 8t, where p of t is measured in feet. Find the net distance from t is equal to 0.5 minutes to t is equal to 1.5 minutes. Will the net and total distance be the same? So first, let's find that net distance. Which is going to equal to the absolute value of p of 0.5 minus p of 1.5. So let's go to the calculator and let's graph this function. I'm just going to clear out these equations since I don't need them anymore. All right, so e raised to the 2t, so just x, minus 8x. And let's graph. All right, so let's go ahead and get those values. So second calc, value, let's do p of 0.5, which is negative 1.2817. So negative 1.80817. Oops, just kidding. Negative 1.2817. That's what I had said, obviously. Okay, and now let's do p of 1.5. So 1.5, and we get 8.0855. Now we can go ahead and put this on the calculator to calculate this value for us. So we'll quit. Negative 1.2817 minus 8.0855. And we get negative 9.3672, which the absolute value of that is 9.3672, and my distance here is in feet. So this is my net distance. Now to figure out if the net distance will be the same as the total distance, we need to figure out if the velocity will change signs. Because if it changes signs, it changes direction. So we need the equation for the derivative of p, which is v of t. And the derivative of that would be the derivative of the exponent, which is 2, and then copy e to the 2t minus 8. So we're going to make it equal to 0 so we can see if there is a critical number. And let's see if that exists. So I'm going to go now again to my y is equal to menu. I'm going to deselect this, which actually we don't really need it anymore, so we can clear it out. I'm going to put 2e e raised to the 2x minus 8. Let's graph. All right, we can see that there is a critical number right here. So that means that my particle for this section is moving to the left, and then afterwards is moving to the right. So we need that value of t. So let's go to the second calc menu, and we're looking for the 0. Oops. All right, so left bound, right bound, and we get 0.6931. Now for our answer. Since the particle changes direction at t is equal to 0.6931, then the net distance will not equal to the total distance. Let's look at this second question here. The position of a particle is given by the function p of t is equal to t plus 2 sine t, where p of t is measured in feet. Find the total distance from t is equal to pi over 6 minutes to t is equal to 5 pi over 4 minutes. So we want just the total distance. So if I want the total distance, we're going to need to check if my particle changes direction. So once more, we need the velocity equation to see if it does change direction. So v of t, which is my derivative, is going to be 1 plus 2 cosine t. We'll make it equal to 0 so that we can solve for my critical number. So let's go ahead to the calculator once more. We're going to clear this one out. 1 plus 2 cosine of x. And I'm going to actually adjust my window here. Let's do from pi over 6 to 5 pi over 4. Now we can see that right here at the x-intercept, that's where my particle is changing direction. Because since the velocity is positive, that means the particle was moving to the right, and then afterwards it was moving to the left. So we need that value. So we'll go to second calc and find the 0. We go to the left of the 0. We go to the right of the 0. Guess. And we get a value of 2.0943. So now to find the total distance. That's going to equal to p of my starting position, which is pi over 6, minus p of that change in direction, 2.0943. Then I'm going to add the distance from p is p of 2.0943 minus p of my ending position, which is 5 pi over 4. So now I'm going to go back to my calculator. I'm already done with my derivative, so we can actually clear this out. And now we're going to graph the actual position function. So here we go. X plus 2 sine x. Enter, and now let's graph it. So we're going to go to the second calc menu and get the value. And we're going to put second pi divided by 6. And now we get the actual value, so 1.5235. Now we're going to get the value of 2.0943, so we can just directly go from here and just press the number. and we get 3.8264. Plus, now we already have this value, right? So we can just copy it down. 3.8264 minus p of 5 pi over 4. So let's go ahead and get that value, which is 2.5127. Now we can do the subtraction and then add everything together. So I'm just going to quit from here. So 1.5235 minus 3.8264 is negative 2.3029, which of course the absolute value of that is positive 2.3029. Plus, now let's do the other one, 3.8264 minus 2.5127, and that gives us 1.3137. If we add these together, we end up with 3.6166. Don't forget the units, which is feet. So that is my total distance. Now let's move away from the calculator and look at a non-calculator FRQ. Okay, so we're told here that a particle moves along the x-axis with velocity at time t is greater than or equal to 0, given by v of t is equal to negative 1 minus e raised to the 1 minus t. Find the acceleration of the particle at t is equal to 3. So if we're finding acceleration is the derivative of velocity. So I need to find the derivative of this equation. The derivative of negative 1 is 0. The derivative of negative e raised to the 1 minus t, well, we would get the derivative of the exponent, which is negative 1, times the function, so negative e raised to the 1 minus t. The negatives just basically cancel out, and my velocity, the derivative of velocity, so acceleration, is e raised to the 1 minus t. So we want to find the acceleration when t is equal to 3. So a of 3 is going to equal to e raised to the 1 minus 3, which gives me e raised to the negative 2, which can be rewritten as 1 over e squared. Now we're not given units, so you don't have to worry about it. This would be my answer. For B, is the speed of the particle increasing at t is equal to 3? Give a reason for your answer. To figure out if speed is increasing or decreasing, we would have to compare the signs of both velocity and acceleration. I already have the acceleration when t is equal to 3, which is 1 over e squared, and that is a positive number. So now I just need to find the velocity when t is equal to 3. So if I plug that in, I get negative 1 minus e raised to the 1 minus 3, which is equal to negative 1 minus e to the negative 2, which again is equal to negative 1 minus 1 over e squared. Now, no matter which way you look at it, this is a negative number because we have negative 1 and then we're subtracting this fraction. So we would say the speed of the particle is not increasing. You always want to make sure that you're answering the question directly. I know that I could say that the speed of the particle is decreasing, but it's asking if the particle is increasing. So we want to make sure that we relay our answer using their wording. So we would say that the speed of the particle is not increasing because v of 3 and a of 3 are different signs. Remember, if they were the same sign, then the speed would be increasing. Okay? For part C, find all values of t at which the particle changes direction and justify your answer. So when we're talking about justifying your answer, especially if you're just finding a value, if there's no theorem involved or anything like that, then we're basically just showing our work. So we know that the velocity would change direction, the particle would change direction if the velocity is equal to 0. So let's set the velocity equation, which is -1 minus e raised to the 1 minus t equal to 0. So let's isolate this e. I would have to add the 1. So we have -e raised to 1 minus t is equal to 1, and then divide by -1. So we get e raised to the 1 minus t is equal to -1. In order to cancel out the e, you would have to apply ln to both sides. This would cancel, and I'm left with 1 minus t is equal to the ln of -1. Now keep in mind that the ln of -1 does not exist. Okay, ln is only defined for when t or x or whatever variable is greater than or equal to 0. -1 is less than 0. So this means that there is no solution. So what we can say here actually to justify our answer is the particle never changes direction because v of t does not equal to 0. Last part here, the function p of t is equal to 1 minus t minus t models the position of the particle for t is greater than or equal to 0. Find the total distance the particle traveled on the interval 0 to 3. Since the particle never changes direction, as we saw in part C, that means that the total distance is going to equal to the net distance. So really, all we have to do here is to find total distance, we would do p of 0 minus p of 3. Remember, this is a non-calculator FRQ, so you are not expected to actually find those decimals. You can just leave your answer like an expression. So p of 0, if I plug it in, that's going to be e to the first minus 0. So if you want, I'll write it here on the side. E to the 1 minus 0 is just going to equal to e, because e to the first is just e. Now p of 3 is going to equal to e of 1 minus 3, which is the same thing as saying e raised to the -2 minus 3. So bottom line, this means that my total distance is going to be the absolute value of e minus e of -2 minus 3. And you can leave your answer like this, or you can distribute that negative, and it would be e minus e raised to the -2 plus 3. And you can also rewrite this negative exponent as 1 over e squared, or leave it like this would be fine as well. And this would be your total distance. Let's look at another non-calculator FRQ. A car is traveling along on a straight road for t is between 0 to 24 seconds. The car's velocity in meters per second is modeled by the piecewise linear function defined by the graph below. So even though my graph isn't labeled, I'm going to label this right now so we don't forget that this graph here represents v of t. Find the value of v prime of 4 and v prime of 20, or explain why it does not exist. Indicate units of measure. So let's start with v prime of 4. If I go to 4, what I have here is a cusp. So that means that it is undefined because of the cusp. It's not differentiable. So v prime of 4, we can say does not exist or is undefined is more likely because v of 4 is not differentiable. And you can even be more specific and state because of a cusp. Now v prime of 20, if I go to 20, I am on that line. So in order to find v prime of 20, we need the slope of this line. So you can basically just, count, right? The rise over run. So this is going to be negative because I'd have to go down. So this is negative 20 over, and then this is 16 to 24, which is 8 units. And negative 20 over 8 can be simplified to negative 5 over 2. And our units here, because this is in meters per second, this is acceleration, so this will be meters per second squared. For B, for what intervals of time does the car have 0 acceleration? A 0 acceleration means that the slope of the line would be 0, right? Because since A acceleration is the derivative velocity, we want the part of the line here that would have a slope of 0. And so we would say A of t is equal to 0 on the graph when v of t is constant, because that would indicate that there is 0 slope, which occurs on the interval from 4 to 16. For the interval of 0 to 24, write a piecewise defined function for the car's acceleration a of t. So remember, this is what we did in the previous lesson. To find a piecewise function for a of t, we need the slope of all of these different parts. So in this first part, the slope of this line is 20 over 4, so 5. And that would be on the interval from 0 is less than t is less than 4. Then we already stated that the slope here is 0, and that's on the interval 4 is less than t is less than 16. Finally here, we found this slope already. That's this number, right? So that is negative 5 over 2 on the interval 16 is less than t is less than 24. And that would be my piecewise function. Now for part D, find the average rate of change of, there's an of here that should not be here. Find the average rate of change over the interval 8 to 20. Does the MVT guarantee a value of C on the interval 8 to 20 such that V prime of C is equal to the average rate of change, why or why not? So let's first find the average rate of change from 8 to 20. So this, because we're finding the average rate of change of velocity using the velocity graph, that means that we're finding average acceleration. And that's going to be v of 8 minus v of 20 over 8 minus 20. v of 8 is 20, and v of 20 is 10, over 8 minus 20, which is negative 12. 20 minus 10 is negative 10 over negative 12. And when we divide, or rather simplify, 10 over 12 is 5 over 6, and then our units, which is meters per second squared. Now for the second part of this question, it says, does MVT guarantee a value of C, etc., etc.? MVT, remember, is only applicable under two conditions. One, that the function is continuous, which it is, and 2, that the function is differentiable over the interval. Now, if we're looking at from 8 to 20, we have a cusp here. So that means that over the interval, we have a point where it is not differentiable, therefore MVT is not applicable. So we would say MVT does not guarantee a value of C such that V prime of C is equal to V of 8 minus V of 20 over 8 minus 20, because V of t is not differentiable at t is equal to 16. All right, now let's have a look at some multiple choice questions. An object moves along a straight line so that any time t between 0 and 9, its position is given by x of t is equal to 7 plus 6t minus t squared. For what value of t is the object at rest? If the object is at rest, that means that the velocity is equal to 0. Because that means it had to stop and then it's going to change directions. So we need the derivative of this and then we set it equal to 0. So v of t is going to equal to 6 minus 2t. And we make it equal to 0. So we subtract the 6. Negative 2t is equal to negative 6. And then divide the negative 2. So t is going to equal to 3. So in this particular question, it's not like the math was actually hard to do. It's more of just knowing what it is that you're supposed to do. So if an object is at rest, that means that it's not moving, so its velocity must be 0. Now for this last question here, this is a calculator question. A particle moves along a line so that at time t, where t is between 0 and pi, its position is given by s of t is equal to negative 4 cosine t minus t squared over 2 plus 10. What is the velocity of the particle when its acceleration is 0? So for this one, what we need to do is find out the time when the acceleration is 0. So this is the first thing that I need to figure out, is that t value. So what I'm going to have to do is take my position function and find the second derivative. So my first derivative is going to be positive 4 sine t, since the derivative of cosine is negative sine, and that would cancel out that negative, minus, when I bring the 2 forward, it will cancel out with the 2 in the denominator, so t. Now my acceleration is going to be 4 cosine t minus 1. So we're going to make this equal to 0 so that we can solve for t. So let's go on the calculator. I'm going to clear this out. I'm also going to adjust my window here. So I have 0 to pi. Okay, so I'm going to graph my acceleration, which is 4 cosine t minus 1. And we can see here that we do have an x-intercept, so we're going to get that value. And we get the x-intercept of 1.3181. Now the question is asking, what is the velocity of the particle at this time? So that means I'm going to take this number and I am now going to plug it in to my velocity equation. Now you can do one of two things. You can just go to the calculator and plug in those numbers, or you can graph the function and then find the value. I usually just like to graph the function and then find the value. So 4 sine x minus x. Just because I like doing it this way because the calculator is the one that does all the work. And if I were to input, I mean, this is a simple equation, but sometimes if you have a more complicated equation and you're plugging in a number to get the function value, sometimes if you put a parentheses in the wrong place or you might press the wrong button, etc., etc., it could make things a little bit more difficult. So I just like to graph and then find the function value in option 1. So let's plug in 1.3181. And we get the value of 2.5548. So C. Now notice that they have this value here, here. And that's because it's kind of, not to trick you, but it's kind of, well, sort of, yeah, it's to trick you. Because this would mean that you found the value, but you're just not done. So just make sure that, you answer what the question is asking. Okay, and that wraps it up for distances and particle motion.